So now we will be taking the derivative of the same function that we had just taken the derivative of in our previous video. However, in that one we had used implicit differentiation. In this one we will be using logarithm properties, where we assumed that y was equal to x to the x, and then we took the ln of both sides, and then we differentiated both sides of the equation. This time we are going to rewrite the function using a logarithm property, where it is that a to the power of b is also equal to e to the b times the ln of a. These are equivalent statements because essentially e and ln are going to cancel each other out. So a to the b is equal to e to the b times ln of a. So what we want to do is we want to rewrite this function in that form right over here. So we know that both our a and our b are going to be x in this case. So x to the x, a is equal to x, b is also equal to x. So we can rewrite this function as e to the x times ln of x. So this is e to the x times ln of x. And essentially what we can do over here is we can use a chain rule application, because this is essentially an x times ln of x trapped within an e to the x function. So we've got f of x, which will be our outer function, g of x will be our inner function, and then f prime and g prime will be their respective derivatives. So our outer function is going to be e to the x. Our inner function is x times ln of x, and we already derived that in the previous video. So if you'd like to see how it is that you take the derivative of x ln of x using the product rule, go ahead and check the implicit differentiation version of this derivative. So our f prime is going to be the derivative of e to the x, which is e to the x, and then g prime will be the derivative of our g of x, which is x ln of x. The derivative of x ln of x is ln of x plus 1. So now all we need to do is take f prime, plug in our g, and then multiply the entire expression by g prime. So if we wanted to do that, this would be wherever it is that we see x here, we will substitute in our g. So this will become e to the x ln of x multiplied by g prime, which is ln of x plus 1, all in brackets. Now what we can do in order to receive the same result that we got in the same video is we are going to rewrite this a little bit so that we will have e to the ln of x all raised to the power of x. So we're going to do a slight modification right over here, but we're not going to be changing the value of our expression. We're going to write that e to the x ln of x is equal to e to the ln of x all raised to the power of x. And these are equivalent statements. They mean the exact same thing, because if you were to raise this to this power, essentially what you'd have to do is multiply out the exponents. So e to the x ln of x is equal to e to the ln of x times x, and the e and the ln are going to cancel each other out. So e to the ln of x is none other than x itself. So this entire expression can be rewritten as x to the x, because this whole thing becomes x raised to the power of x, which we've got right over here. So this becomes x to the x, and this is ln of x plus 1. Once again, if you'd like to distribute that, go ahead. It's going to give you x to the x ln of x plus x to the x, and that's how you would take the derivative of x to the x using the chain rule and logarithm properties.